Welcome back, Calculus 2 students, to another math review. Here we're trying to find the integral of x to the third times the root of 1 minus x squared dx. First thing you should notice about this function is this integral is that it has a trigonometric identity of a squared minus x squared, which is equal to cosine theta, where x is equal to a sine theta, where a is just 1. Dx is equal to then cosine theta d theta. Substituting all this back into the integral, we get integral sine to the third theta. This root turns into cosine theta, and this dx turns into cosine theta d theta. To reduce this integral a little bit, we're going to get the integral of sine to the third theta, cosine squared theta d theta. Now we need to apply a trigonometric identity of 1 minus cosine squared theta to a sine squared theta. And we also need to do a u substitution of u equals cosine theta, where du is equal to negative sine theta d theta. Substituting all that back into the integral, we get integral 1 minus u squared negative du. This negative was taken from the negative sine theta d theta and put into the du. This trigonometric identity was put into the sine squared theta, and this times and the sine theta that's left over here was combined with the d theta to get this substitution. And because of this trigonometric identity, we have a u squared right here. Now we need to take that negative out of the integral so that we get negative integral. And if we put this u into this equation, we'll get u squared minus u to the fourth du. After this step, we now need to separate the integrals because of the additive or subtractive property. So then we'll get the negative integral u squared du plus, because this u to the fourth is being subtracted from this u to the u squared, and this negative outside of the integral is also being applied here to this subtraction symbol to get an addition symbol. So plus integral of u to the fourth du, which when you integrate this equals negative u to the third over 3 plus u to the fifth over 5. Now we need to substitute the u's that we have here for cosine thetas, which will give us negative cosine to the third theta over 3 plus cosine to the fifth theta over 5. Now, we're not done yet. We have to now turn our cosine thetas back into our original trigonometric identities that we started with. So this will end up with a final answer of negative 1 over third times root 1 minus x squared to the third plus 1/5 times the root of 1 minus x squared to the 5th plus c for the constant of integration. And that is how you solve for this integral.